Hello again. This is my second recording related to synchronization chapter. I will continue from user mode versus kernel mode. Actually, this slide is, I put it just to explain the difference between user mode and kernel mode, because in the other slides it is mentioning. By the way, user mode is something like in the operating system, you are programming the system by using just software or with applications, or we can say the application part of the system, user mode. And the kernel mode are actually have access to directly hardware, and it is a kind of core mode of the system, which the core operating system components run in kernel mode. So when we say something in user mode, you can understand that it is an application, or it is a kind of application that it is designed. So it is not related with the hardware of the system. Okay. As I mentioned in the beginning of the first lecture, there are some mechanisms or some mechanisms applied to solve the synchronization and to avoid race condition kind of problems. So lock variable is the simplest synchronization mechanism. And as you see, it is a software mechanism implemented in user mode. So we can understand that it is a kind of software, not a kind of hardware, or we are not going to just change some hardware values. This is a busy waiting solution, which can be used for more than 2 processes. Okay, in this mechanism, lock variable lock is used. So the lock values can be possible either 0 or 1. And if the lock value is 0, it means that the critical section is vacant, so accessible. And while lock value is 1, it means that it is occupied. So if a process wants to get into the critical section, so let me to tell you again, think about there are 2 processes, and each process have critical section related to one memory area or memory space. So that critical section is the place that in the software or that process that they are aiming to use that memory area. So, and it is a critical section because the other process is also wants to use it. So just think this one first, and then I will continue. So a process which wants to get into the critical section first checks the value of the lock variable. So it will check if lock variable is 0 or 1. If it is 0, it sets the value of lock as 1 and enters into the critical section. So you can think like that. If the toilet is vacant, you can go inside and then you will turn it to occupied, something like that. So actually, the thing is, the lock variable is doing is exactly the same. Okay, so when no one inside, it is vacant. When someone inside, it is occupied. And this occupied will be done by the user. Okay, so as I told before, if the lock variable is 0, then it sets the value of lock as 1 and enters into the critical section. Otherwise, it waits if it is 1. It means that someone else is using it. Okay, when we check the image here, we can see that there are 3 sections in the code. Entry section, which here we are testing if the lock variable is 0 or not. And if it is 0, it means the critical section is vacant. Then we can use it, so no one is in critical section. In other words, we will make it 1 to show the others that someone is using the critical section, and enter to the critical section. And then when system quits from critical section, it will just turn lock variable to 0 again in the exit section. Okay, so the entry section is the place that we are checking if the lock variable is 0 or not, and just make the lock variable 1 if it is 0, if it is vacant. And critical section, the place that we are just reaching that memory area. And then when we finish, our program will set the lock variable value to 0. Okay, so it is here, there's a while loop, and it is keeping the process here waiting unless the lock variable is equal to 0. So when it is equal to 0, it will just continue to the next step. So otherwise, it will just run the while loop and process continue waiting here. I mean, the system to enter the critical section. And as you see, the process will wait infinitely if the lock value is 1. So while lock is not equal to 0, it will continue to check it again and again until the value equals to 0. Okay. And as I told you, when the process exits from the critical section, it reassigns the value of log as 0. Okay. In the beginning, I again told you, and we explained in detail, that each synchronization mechanism is judged on the basis of 4 conditions: mutual exclusion, progress, bounded waiting, and portability. So let's check this system according to these mechanisms, but okay, we will see what will happen. Okay, analyzing the log variable. So here we can say that it is a must about mutual exclusion and progress to be run properly or provided by any solution. So let's analyze that. The log variable mechanism doesn't provide mutual exclusion in some of the cases. What was the mutual exclusion? Only one process at a time can use the critical section. But here we will see an assembly code that it will just says opposite of this in some cases. Okay, as you see, the programs are just converting to the machine language, and assembly code is actually the closest part of machine language. And here, let's see the conversion of the previous code. Let's see how it is happening. First of all, the log value will be stored into R0 in the first step. Then we will check R0 value with 0. I mean, we will compare. If R0 is 0, we can just jump to the next step. Let me to say, if R0 is not 0 in the third one, it will go to the beginning. Otherwise, it will continue to the fourth step. It will store 1 to the log. So actually, what we are doing in first 3 step, actually, we are just checking our while loop, but it is doing it in 3 steps in assembly. And the fourth one is the one that when the process understand that the log value is 0 and enters to ready to enter to the critical section, the first thing that it will do to set the log value as 1, and then it will enter the critical section. And when it is finished, it will store 0 to the log. So this is how it happens. But there are some conditions that this system is not be successful. We will see that. Okay, consider that we have 2 processes, process 1 and process 2. The process 1, P1, wants to execute its critical section. Then P1 gets into the entry section. Since the value of log is 0, P1 changed its value from 0 to 1 and enters into the critical section. So P1 changes the value from 0 to 1. So here log value will be 1. Meanwhile, P1 is preempted by the CPU, which means that CPU will schedule another process, and P1 will be moved to the ready queue. So now there is no other process in the critical section, and the value of log variable is 0. So now P2 also wants to execute its critical section. It enters to the critical section by setting the log variable to 1. So now CPU changes P1 state from waiting to running. And P1 is yet to finish its critical section. And P1 has already checked the value of the log variable, and it remembers that its value was 0 when it previously checked it. Okay, here the log variable here are 0 is still 0. So it means that actually the process is not checking the updated value of log variable. It is checking its register value that it saved the log variable. Okay, so it is checking the register value, and it's because of it is 0, it thinks that still that critical section is vacant. Because of that, it remembers that it is 0, as I told you, and it also enters to the critical section without checking the updated value of log variable. So this is the problem. Now we got two processes in the critical section. According to the condition of mutual exclusion, more than one process in the critical section must not be present at the same time. So because of this kind of situations, the log variable mechanism doesn't guarantee the mutual exclusion. And as you know, this is the actually most important part, ensuring the mutual exclusion. So because of that, the log variable doesn't provide the mutual exclusion. It cannot be used in general, and because of it is failed at the first step, which it is the most important one, we don't need to talk about the others. Okay, so because of this kind of problems, they try to make this algorithm better by adding test set log mechanism. As we discussed in the previous slides, in log variable mechanism, sometimes process reads the old value of log variable and enters the critical section. Due to this reason, more than one process might get into critical section. So this is a very big problem. Here, there's a modification of the code, assembly code. However, the code shown in the part 1 of the following section can be replaced with the code shown in the part 2. So, what was the first section? We are loading log variable to putting log variable to R0. We were comparing R0 with 0. Then if it is not 0, we will move to the step 1. And if we are in step 4, if we come to step 4, it means that our log variable is 0. So actually, this is the problem in the previous slides that I explained. So system knows that the log variable is 0, and because of it is it didn't check the current value of the log variable when it is come back the process 1. It will go to the critical section and also with the another process. So that's why mutual exclusion is not guaranteed always. How we can modify it? We can do it without we can just store the log value 1 immediately, and we can say that in register 0 we have the actual log value, which it is either 0 or 1, and in the inside log variable we have 1 in second step. So, and the system works similar. When R0 is equal to 0, it will just move to the critical section. If not, it will move to the beginning of the loop, of the code. So it will move to the step 1. So in this case, this will help us that we can have we can modify the log variable in second step to 1. So in the updated version of code, the value of log is loaded into the local register R0, and then value of log is set to 1. However, in step 2, 3, the previous value of log is compared with 0. If it is 0 here, the system will simply enter into the critical section and the log value is already 1. So otherwise, it will continue to execute the loop. The benefit of setting the lock immediately to 1 by the process itself is that now the process which enters into the critical section carries the updated value of lock variable, that is 1. So in the case when it is preempted and scheduled again, also it will not enter the critical section regardless of the current value of the lock variable, as it already knows that what the updated value is lock variable is. So before entering, we make it. That's why if in any case it is preempted, it will know the updated value of the lock variable. By the way, this solution provided in the above segment, I mean the previous slide, it provides a mutual exclusion, but it doesn't make sure that the mutual exclusion will always be there. There's a possibility of having more than one process in the critical section. How? What if the process gets preempted just after executing the first instruction of the assembly code written in section 2? In this case, it will carry the old value of lock variable with it, and it will enter into critical section regardless of knowing the current value of lock variable. And this will also make 2 processes present in the critical section at the same time. It is saying, what if after the first step, which it is just store the lock value into R0, it still knows that and preempted. Again, it knows that it is vacant. So also someone else will just see it, it is 0 lock variable and enter the critical section. And then when it comes back, it may enter the critical section as well. So actually, to solve this, the first and the second step should be used in one instruction. As I told you, problem can be solved if we can be able to merge the first 2 instructions. In order to address the problem, the operating system provides a special instruction called test set lock. So this instruction is doing this 2 instructions task. It is loading the lock variable value into R0 and just setting the lock value as 1. And the process which executes the TSL first will enter into the critical section, and no other process after that can enter until the first process comes out. No process can execute the critical section even in the case of preemption of the first process. So this one is also interesting because it will wait for preemption for the other process and come back to finish it. So the 4-line assembly code will be decreased to 3 lines, And as you see, the first line TSL lock R0 is actually, it is assigning the current lock value to R0 and then turn lock value to 1. So let's examine this one, updated version of our system. Okay, mutual exclusion is guaranteed in TSL mechanism since a process can never be preempted just before setting the lock variable. Only one process can see the lock variable as 0 at a particular time, and that's why the mutual exclusion is guaranteed. So even if it is preempted, no one else can enter there. But according to the definition of the process, a process progress. What was the progress? If someone else does not using the critical section, the other process should enter or should not just make a kind of obstacle between them. So a process which doesn't want to enter the critical section should not stop the other processes to get into it. In TSL mechanism, a process will execute the TSL instruction only when it wants to get into the critical section. So the value of the lock will be always 0 if no process doesn't want to enter into the critical section. Hence, the progress is always guaranteed in TSL. So also, bounded waiting is not guaranteed. Some process might not get a chance for so long because to wait for the other process. We cannot predict for a process that it will definitely get a chance to enter in critical section after a certain time. The architectural neutrality, it is not provide architectural neutrality because it was platform independent. It should be platform independent to be architectural neutral. So we don't know that this instruction is provided by all the operating systems or platforms. Some platforms might not provide that. So it is not architectural neutral. So it is just have mutual exclusion and progress, but bounded waiting and portability or architectural neutrality is not satisfied. Okay, I will stop and continue from Patterson solution in next lecture.